Welcome all. In this session, we will discuss about ternary operator programmatically. In our earlier session, we have discussed about ternary operator theoretically. Now let us implement ternary operator program. Okay, so here ternary operator comes under something like conditional construct only. So let me say text document ternary operator. Now let me provide ternary operator. Now what is this particular ternary operator? So it is nothing but question mark and colon. Now ternary operator comes under conditional construct because it is going to evaluate the condition. So let me say syntax is nothing but condition followed by colon followed by true statements colon followed by false statements. Now here what is happening, whenever the provided condition is true, whenever what are the condition that we are providing, if the result of the condition is true, it is going to execute these particular statements after represented with question mark. If the condition is false, it is going to execute false statements, nothing but the statements that are represented after colon. So these are nothing but the true statements and these are nothing but the false statements. So let us see an example based on this particular ternary operator. Now what I'll do, I'll just go with int x equals to 10 comma y equals to 5 comma z. Now what I'll do, z is equals to the condition x is greater than y. So if x is greater than y, so question mark return this particular x or colon return this particular y. Then terminate it. So what I'll do, I'll just say printf within the double quotation, say z is equals to %d, move the cursor to the next line, comma z. Now save it, compile the code and run the code. So what is happening, we are getting this particular z value called 10. Suppose if I am providing y value called 50, now 10 is greater than 50, no. The condition is false, the content that is provided after colon will be getting written, nothing but y value is getting stored in z, so it is going to display the z value called something like 50. Suppose if I am providing x value called 100, now 100 is greater than 50, yes, so it is going to get the content called that is represented after question mark, nothing but true statements. So x value is getting stored in z, now z value is equals to 100. Okay, so this is a small example related to the ternary operator. Now what is happening, I just want to go with one more example where I just want to print the message. So what is happening, let me directly provide x is greater than 5. So question mark and colon. So in place of question mark, let me say something like printf, I just want to say something like x is greater, and in place of y, I just want to say something like printf and y is greater. So this is a small code. Save it. Now compile the code and run the code. And let me say comma x and let me say comma y. And let me say semicolon x. Save it. Compile the code. We need to return the value. So what I do, I just represent this particular thing within if block. So entire thing z equals to. Save it. Now compile the code. Or else we say returning the value called 1 and here I am returning the value called 0. Then what you can do, directly you can say something like if z value is equals to 1, then you can say something like printf, I just want to say something like x is greater, else I just want to say something like printf, or else if z value is equals to 0, then we can say that y is greater. So let me save the program, compile it and run it. So x is greater, now let me provide y value as 500, save it, compile the code and run the code, we are getting y is greater. Now if I want to achieve this particular previous code, directly if I want to display the value, we have an interview question where I just want to display a message in the output window without using semicolon. So in that case, what is happening? I just want to say something like if say open and close braces, 100 is greater than 50. Then what is happening? Question mark, just say printf, my message is hello, or x is greater, or just let me say hello, hello, and colon, let me say printf, and here I just want to say something like hi. Then let us have the block for this particular if block. So if 100 is greater than 50, yes, it is going to print hello. Otherwise, it is going to print hi. So save the code, compile it and run it. So it is going to print hello. Let me make this one as 500. 100 is greater than 500. No, false. So it is going to execute the colon content, nothing but hi. So compile it and run it. So we are getting something like hi. So copy this particular thing and let me paste it over here. And for this, we are having a question. So write a C program to display hello in the output window without using semicolon. Okay, so this is the logic. So we are using this particular ternary operator within the if block in order to represent this particular code. So this is the simple concept related to ternary operators. In the earlier session, we have discussed about the theory part related to bitwise operators. Now let us see the programming related to the bitwise operators. So what are the bitwise operators we are having? So let me open a notepad and I just want to say bitwise operators demo. Now let me open this particular thing and let me provide the heading called bitwise operators. So what are the bitwise operators? Bitwise AND, bitwise OR, bitwise XOR, and bitwise negation, and bitwise left shift followed by bitwise right shift. So these are nothing but bitwise operators. So let us have the first one, AND. So generally we call this one as bitwise AND. So what is the use of this particular bitwise AND? So bitwise AND, or it is going to take, it is taking two numbers as operands and does the AND on the every bit of two numbers. Now before getting into this particular thing, bitwise operators has to be used only on the integer type of data. Bitwise operations will be implemented based on the binary value. That is, we are implementing binary addition, or we are implementing operations on binary data. Okay, so when it comes to bitwise AND, it is going to take two numbers as operands and it is going to perform AND operations on every bit of this particular two numbers, and the result of this particular AND is 1 if both bits contains 1. So every bit, something like both bits contain 1 means first operand bit value is 1 and second operand bit value is 1, then only it is going to implement something like, then only it is going to return 1. Followed by, let me go with the second one, OR. So we call this one as bitwise OR. So it is also going to take two numbers as the operands. Let me copy it and paste it. Two numbers as the operand, and it is going to implement OR operations on every bit of this particular two numbers, and the result of this particular OR is 1 if any of the bit contains 1. So number 1 contains 1 and number 2 contains 1, the result will be 1. Number 1 contains 0, number 2 contains 1, the result will be 1. Number 1 contains 1, number 2 contains 0, so the result will be 1. And both the numbers contain 0 bits, so the result is 0. Then let me go with third one, nothing but XOR. So we call this one as bitwise XOR operator. So let us see. Now when it comes to this particular thing, it is also going to take two numbers as operands and does XOR, nothing but XOR operation on every bit of this particular two numbers. The result of this particular XOR is 1 if any of the bit contains 1. Then the result will be, result of XOR will be 0 if both the bits contains 1 or 0. If both the bits contains 1, the result will be 0, and both the bits contain 0, the result will be 0. If both the bits contain different values 0 and 1 or 1 or 0, it is going to return the value called 1. Then let me go with the fourth one. So nothing but the negation operator. So let me say something like bitwise not. So coming back to here, this particular thing is going to take one number and implementing inverts all the bits of that number. Okay, we will see that particular part. Then let me go with the fifth one, is nothing but left shift operator, bitwise left shift. So what is happening when it comes to this particular thing? Takes two numbers and left shift the first number, left shift the bits of first number, and second operation, and so simply left shift the bits of the first number based on the value provided as the second number. If the second number value is 1, it is going to left shift for one single time. If the second number value is 2, it is going to implement left shift for 2 times. Let us see that particular part also. Right shift, nothing but bitwise right shift operator. Now coming back to the bitwise right shift operator, it is also going to take two numbers and implementing right shift the bits of the first number based on the value provided as the second number. If the second number value is 1, nothing but the first number is implementing left shift for one single time. If the second number value is 2, nothing but right shifting the first number for 2 times. Okay. So if the second number value is 3, implementing the first number right shift for 3 times. So this is the content related to the bitwise operators. Now let me have the examples for these particular bitwise operators. So let me copy this particular thing and paste it. We are implementing the programs. So bitwise AND, bitwise OR, bitwise XOR, followed by bitwise NOT and bitwise left shift followed by right shift. So let me open this particular thing and I just want to have two numbers. Say, let me say int x comma y comma z, where x equals to, let me say something like 10 and y equals to, let me say something like 15, and say z equals to x bitwise and let me say y, then followed by printf this particular z value. So let me say z is equals to %d, move the cursor to the next line, comma z. Now compile the code and run the code. So we are getting this particular output called 10. So let me say here output is nothing but z equals to 10. That we have already explained in the theory part of this particular bitwise AND. So let me copy the code and paste this particular code over here. Then what is happening? Let us go with the next one. The same program that we are implementing bitwise OR. So in place of AND, let us implement bitwise OR kind of thing. Now what is happening? Let me compile this program and run the program. So we are getting this particular z value as 15. Control A, Control C, and let me paste this particular code over here. So what is happening? X value and Y value. So we are implementing XOR. So when it comes to this particular AND, what is the binary format of 10? So it is nothing but 0 0 0 0. Then what is happening? 1 0 1 0. And binary format of this particular 15, 0 0 0 0 and 1 1 1 1. Then what is happening while we are implementing this particular thing? What is happening? We are saying AND. So 0 0 0 0. So 1 1 is 1. 0 1 is 0, 1 1 is 1, 0 1 is 0, nothing but this particular value is nothing but 10. So 10 is getting stored in Z. So let me comment this particular code. Then what is happening? We are implementing the same part, copy it. So X and Y, so we are having this one. When we are implementing this particular OR, the result is 0 0 0 0, then 1 1 is 1, 0 1 is 1, 1 1 is 1, 0 1 is 1. This is how it is implementing. Now let us go with bitwise XOR. Bitwise XOR. Same, I just want to say x, y, z, x equal to 10, y equal to 15. So we are implementing bitwise XOR. So if both the values are 1, it is going to return 0. If both the values are 0, it is going to return 0. If both the values are nothing but not equal to each other, nothing but 0, 1 and 1, 0, so it is going to return true for it. So when we are implementing this particular z equals to x XOR operator of y, so it is going to return the value called 5. So compile the code and run the code, we are getting this particular value called 5. Let me copy it and let me paste it over here. What is the values of x and y? So we are getting the x and y value as 15. So let me copy and paste it. Then what is happening was we are applying, the result will be 0, 0, 0, 0, both are 1, so 0, 0, 1 is 1, 1, 0 is 1, both are 10 and 15. So what is happening? Both are 1s, we are getting 0, and 0 and 1, we are getting something like 1. So 2's complement, 1 plus 0 plus 2, 4, 4 plus 1 is nothing but 5. So how we are going to implement this particular thing? You need to represent something like, let me provide digits for only this one. 2 power 0, 2 power 1, 2 power 2, 2 power 3. 2 power 3 is what? 8. 2 power 2 is what? 4. 2 power 1 is what? 2. And 2 power 0 is what? 1. So 1 into 1 is 1 and 4 into 1 is 4. 4 plus 1 is nothing but 5. So it is going to display the output called 5. Now let us implement negation operator bitwise NOT. Let me have the program. Something like, I just want to have one single variable and let me say x equals to, or let me say comma y. So x equals to, let me provide the value called 10 and I just want to say y equals to applying negation x. Now in that case, let us display this particular y value. So let me say y equals to this particular y value. So the output will be something like y equals to minus 11. So what we need to do in order to implement this particular negation, first of all, let me write this particular program over here, copy it and let me paste it. Now how we are going to achieve? First, step 1, nothing but binary format of x value. So what is happening? We are getting binary format as when it comes to 8-bit 0, 0, 0, 0, then what is happening? 1, 0, 1, 0. So 8 plus 2 is nothing but 10. Then what is happening? Step number 2 is nothing but negation of x. So nothing but, so what is happening? We are getting something like the values are 1, 1, 1, 1 space 0, 1, 0, 1. Then what is happening? Step number 3 is nothing but 2's complement. That is nothing but negation of x. So already we have negation of x, so we are negating. So the first digit represents sign value. Then when it comes to sign value, so 0 is representing positive and 1 is representing negative. So 0 is representing positive and 1 is representing negative. So in that case, what is happening? First value is hyphen, then 0, 0, 0, then followed by 1, 0, 1, 0. Then to this particular thing, step number 4 is nothing but add 1 to 2's complement. So add 1 to 2's complement. Something like first digit is hyphen because signed digit. So 0, 0, 0, then 0, 0, 0, 1. So we are adding 1 to these particular two numbers. So the result is step number 5. What is this? Result of 2's complement plus 1. This entire thing. Result of 2's complement plus 1 is nothing but hyphen 0, 0, 0. Then what is happening? 1, 0, 1, 1. So here the first one is negative. So we are representing it with 1. So the value is nothing but, so 1 plus 2 is 3. 3 plus 2 power 0, 2 power 1, 2 power 2, 2 power 4. So that's nothing but 8. 8 plus 2 is 10. 10 plus 1 is nothing. So this particular value is minus 11. So minus 11 means this particular value is 11 as it is represented with 1. So its value is negative value. So it is negative 11. This is how we are implementing all the steps. The result of these particular two things. So what is happening? Step 5 is what? Result of, so step 3 plus step nothing but 4. Then left shift and right shift operator. So let us implement that particular part. So we have done second example based on this one, where you have took the x value called 15. So in that case, when you are taking x value called 15, you are getting the negative value called 16. Save it, compile the code and run the code. You are getting minus 16. So Control A and Control C. Now what is happening? Example something like 2. So what is happening? Void main, we are implementing this part. Now what is happening? The same code of first digit, let me provide the same thing one more time. So what is happening? Binary value of x. So what is the x value we are having right now? It is 15. So here also binary value of x. What is the x value we are having? Something like 10. Now what is happening? Yes. So x value of 15 is what? 1, 1, 1 and 1. And the negative value is what? 0, 0, 0, 0. And negative of negative value is what? 0, 0, 0, 0. And we are getting something like 1, 1, 1, 1. And we are adding 1. The result will be what? Something like 1 and 1 is nothing but 10. So 0 and 1 will be getting added to this particular thing. Carry forward. 1 carry forward. Then once again 0. 1 will be getting carry forward. 1 will be getting carry forward. Then once again we are getting 0. So 1 will be getting carry forward. Then what is happening? 1 we are getting 1 plus 1 is 0. So 1 will be getting carry forward. So 0 plus 1 is what? 1. So you are getting this particular value. Now before getting into this part, at the starting itself, let me provide while we are implementing the program. So when it comes to 16 bits, it will be something like 128 followed by 64 followed by 32 followed by 16 followed by 8 followed by 4, 2 and 1. So then what is happening? This is nothing but, we can say something like 2 power 0, power I am just representing in this particular thing. Then you can say 2 power 1, then you can say 2 power 2, then you can say 2 power 3, then you can say 2 power 4, then you can say 2 power 5, then you can say 2 power 6, 2 power 0, 2 power 1, 2 power 2, 2 power 2, 2 power 3, 2 power 4, power 1 and 2 power. So 2 power 7, we need to add one more thing, 2 power 1. So like this. So we are getting this particular, and binary value you can get 10. So 10 binary value is 0. So something like 0, something like 0, something like 0, something like 1 followed by 0 followed by 1 followed by 0. So this is nothing but 16 bits. So similarly you can implement this value over here. So something like 0, 2 power 0 into let me say 0 is equals to something like 0. Then 2 power 1 into 0 is equals to, this is 1 into 0 is equals to 0. This is what? 2 into 0 is equals to 0. Then what is happening? 2 power 2 into 0 equals to 2 power 2 is what? 4. Then 2 power 3 into 0 is nothing but 8 into 0 is nothing but 0. Then what is happening? 2 power 4 into, we are getting something like 1. 2 power, so it is getting 16. 16 into, let me say 1 is nothing but 16. So then what is happening? Then 2 power 5 into, what is happening? We are getting 0 is nothing but 32 into 0 is nothing but 0. Then what is happening? 2 power 6 is nothing but into 0 is nothing but 64 into 0, we are getting something like 0. Then what is happening? 2 power 7 into 0 is equals to 128. So 128 into 0 is equals to 0. So overall we are getting something like total. Say total is nothing but, we are getting say 16. So the entire value is nothing but 16. Now 16, what is happening? 1, 1, 1, 1. This particular value will be 16, and as starting it with 1, so we are getting the value called minus 16. So this is how we are implementing the second example. Okay, so we can even add the same thing over here for the first example. What is happening? 2 power 0 into 1, 2 power 1 into 1, 2 power 2 into 0 and 2 power 3 into this particular value. So 1, 2, 3, 4. So remaining all values are 0, so I don't want to take that particular value. So what is happening when it comes to here? 2 power 0 into 1. 1 nothing but 1 into 1, so we are getting 1. 2 power 1 into, once again 1, so 2 into 1, we are getting 2. Then 2 power 2 into 0. The third digit is 0. Then fourth 2 power 3 into 1. Nothing but 8 into 1. So nothing but 8. 8 over here. So total, what is happening? Let me copy this particular code. Total is nothing but 8 plus 2 is 10 plus 1 is 11 we are getting. And but the first sign digit value is 1. So we are getting something like minus 11. Then what is happening? Let us go with the next one called left shift and right shift. So for that, let me have a variable called x, and I just want to say x equals to 10. I just want to say left shift, how many digits? 2 digits. So we have already seen this particular thing. Then you can say x is equal to percentile d comma x. So it is going to display x is equals to, what are the value? Something like after implementing 2 shifts, nothing but 40. So it is going to get 40 as the value. So control A, control C. Then what is happening? Just provide this particular program. So 10 binary value is nothing but under 8 digits I want to display. So when it comes to the 8 digits, what is happening? Something like 32, say 16, 8, 4, 2, 2, 1. So what is happening when it comes to the 10? 0, 0, 0, sorry, 0, 0, 1 and followed by 0, 1 and followed by 0. Then what is happening? First left shift. So in that case, what is happening? So this 0 is coming at this particular position. 0 followed by 1 followed by 0 followed by 1 followed by 0, and here we are getting 0 as a new value. Then what is happening? Second left shift. So in that case, what is happening? We are getting 1 followed by 0 followed by 1 followed by 0 followed by 0 followed by is going to fill up with 0. Then what is happening? We are getting the result. Result is what? Something like 32 plus 8 is nothing but 40. So how we are getting this particular 40? Just let us represent this one. So till here 32. So let me copy all these things. So copy it and paste it. So what is happening? 2 power 0 into 0. So this is what? 2 power 0. Then this is what? 2 power 1. So this is what? 2 power 2 that we have already learned. 2 power 0 into 0, 0. 2 power 1 into 0, 0. 2 power 2 into 0, 0. 2 power 3 into what you are getting? You are getting 1. So 8 into 1 we are getting 8. Then 2 power 4 into 0. So what is happening? You are getting 0. So 16 into 0 is 0. Then 2 power 5 into 1, 32 into 1. So you are getting 32. Then 2 power 6 is 0, 2 power 7 is also 0. As I haven't represented, let me remove this particular thing. Overall, you are getting the value called 40. Then what is happening? Let me implement right shift operation. So let me have the code for implementing right shift, the same thing. So if you are implementing right shift, so you are getting the value called 2. Save it, compile the code and run the code. You can check here the x value is nothing but 2. Copy it and let me paste it over here and let us implement this particular thing. So 10 binary value. So 10 binary value and first right shift. First right shift and second right shift. So let us implement right shift over here. So this particular 0 is coming over here. This 0 is coming over here. And 1 is getting shifted and 0 is shifted and 1 is getting shifted. So in this place 0 is getting added. So 0. Then what is happening? Once again right shift. So this 0 is coming over here and 16 0 is coming to the 8th position and 8th 0 is coming to the 4th position. 4th 1 is coming to the 2nd position and 2nd 0 is coming to the 1st position, and this value is getting filled by 0. Then what is happening? 2 power 0 into 0, 0. 2 power 1 into 1. So we are getting 2 into 1 is nothing but 2. Then what is happening? All the values are 0. So here also 32 into 0. So we are getting 0. The result is nothing but 2 kind of thing. So we are getting the output called 2. This is how we are implementing bitwise operators. Something like bitwise and, bitwise or, bitwise not. Nothing but negation, bitwise XOR, left shift and right shift operations. Left shift and right shift operations using bitwise operators. These are the bitwise operators related to the programmatic. Programmatically, we have implemented the bitwise operators. Thank you.